I am Project Lead Stephen Mossberger,
Paul Howarth, Mark Sakutis,
Dan Espinosa.
and this is our ME154 project. We are building a Tripteron 3D printer.
The purpose of this project was to create a large volume, simple, cost-effective 3D printer. The motivation for this project is to build a lightweight gantry while we minimize our part variety and parts needed. Most of the parts will be 3D printed, thus reducing our custom, not off-the-shelf parts. We wanted the simplicity of our Cartesian, yet the speed of a Delta. The Tripteron kinematic is made up of 3 4-bar slider linkages attached to a center point, known as the effector. All 3 linkages are orthogonal to each other, and each linkage represents a plane, the X, Y, and Z plane. Extensive print volume are limited by the toggle of the joints. Force from the stepper motor is then transmitted perpendicularly to the axis of rotation of the joints. This then creates independent X, Y, and Z plane motion. Then we head to Fusion 360's FEA, Finite Element Analysis, to find our maximum displacement, maximum stress, and minimum safety factor. First, we start off with our 4-bar slider from either our X, Y, or Z axis. Then we tell the software that we want our material to be a PLA equivalent, which is our 3D printer material. Then we put a force at the very end of the linkage where our end effector would attach, and this force is equal to the entire weight of all 3 linkages combined. Then we took 1 times that weight, 2 times that weight, 3 times that weight, and 4 times that weight as the force. This is also known as 1G, 2G, 3G, and our worst case scenario 4G deceleration or acceleration. Then we are going to look at our 1G results, and we're going to go into our result view to find our minimum safety factor of 7.5 at the shoulder joint. Then we find our maximum stress of 16.72 megapascals at our second shoulder joint, and finally our maximum displacement of 5.301 millimeters at the end of our linkage. We then began to build the Tripteron 3D printer. After all 6 links were 3D printed, we then assembled them to the 4-bar slider linkage. Each 4-bar slider linkage requires 3 joints. Each joint takes 2 608ZZ ball bearings. Then all 3 linkages are attached in the center with an effector, and then at their ends to a linear rail with a shoulder joint. These linear rails control the X, Y, and Z motion. After we finished building our Tripteron 3D printer prototype, we were left with a stiff yet lightweight 3D printer gantry. However, we found that inaccuracies in the 3D printed links and also tolerance issues in the 608ZZ ball bearings, this led to an excess deflection in the end effector. This shows that this 3D printer prototype is inadequate for a 3D printer platform. Thus, more adjustments must be made before a final 3D printer prototype is met. Thanks for watching our Tripteron 3D printer project video.